Hey folks, welcome back to the channel. In this video, we'll be covering the problem grid path. We have been given an n cross n grid, and some of the squares can have traps. It's not allowed to move on to the squares in case they have a trap. Our task is to calculate the number of paths which will stem from the upper left square and end on the lower right square. The constraints are that we can only move right or down. Input is straightforward. We will be given an integer n which will denote the size of the grid, and then we will be given the grids line by line. Star will denote a trap and a dot will denote an empty square. We are to print the number of paths modulo 10 to the 9 plus 7. Let's go over the third process. So here's a sample input. The circles here denote the cells which are free for grabs, and the stars denote the cells which have a trap set on them. Let's find the number of ways for this example. One way could be that we go straight down to the right till this third circle, then go all the way down, and then finally take a right to reach our destination. Second way could be that we go down first, then go right all the way, then go down again, and then go right again to reach our destination. Third will be that we continue on this path, go here, but instead of going to the right, we take the downward path from here and then merge with this path going to the right, reaching the final side. So the number of ways in this case will be 3. We have a total of 3 ways. Now, how will we form the transition equation and how can we solve this problem by breaking it into smaller sub-problems? Let's see that. For this, we'll consider 3 circles. So let's say these are your 3 circles. And this is the circle which we are concerned about. Now, what are the ways in which you can reach this? Either you can reach it by this, following a right, or you can reach it from this circle, following a down. These are the only 2 ways in which you can reach the circle highlighted over here. Let's give these circles their coordinates. Suppose this circle has the coordinate I, comma j. Let me drag this here. Yeah. So this circle has coordinate I, comma j. Simply, this circle will then have the coordinate of I, comma j minus 1. And the circle here will have the coordinate I minus 1, comma j. And these 2 circles are the circles which will be responsible for contributing the number of ways in which you reach I, comma j. So this gives us the transition equation. Let dp of ij denote the number of ways in which you can reach I, comma j from the leftmost corner, which is our starting point. Then dp of ij will be dp of I j minus 1 and dp of I minus 1 j is addition. But here is where one of the problem arises. Suppose one of these cells or both of these cells had a trap. Then those cells are not what we really want in our answer. So to simplify the implementation, we can give each cell a good or bad value. This is how we'll do it. You can define a function g which takes the coordinates which are I, comma j, and it can return a 1 if a cell is good or 0 if a cell is bad. So in our case, we will return 0 if star is what we are encountering, and we'll return a 1 if we encounter a circle. So how can we change the DP equation in that case? Well, we'll simply do this. We'll multiply every value which we are considering with its G value, and that will take care of all the nitty-gritties of the implementation. So suppose if a cell is bad, then its G value will be 0 and we will not consider it for our answer. And if it is good, then the value of the same cell will be good and we will consider it for our answer. Finally, we'll take, perform the modulo operation on this quantity, which is on the right hand side, and that will give us the actual value which we want to print. Let's see how it looks in code. So here's the G function which I was talking about. We are taking a character as an input, but you could have taken I, comma j as input as well. So if the character represents a dot, then I am returning a 1. Otherwise, I am returning a 0. We initialize the DP array and the grid array. And DP of 00 is basically the G value of the cell 00. Then we iterate over the cell and check if the indices are valid or not. That is the ones which we are checking. So if j minus 1 is greater than or equal to 0, then we check if we can come by performing a downward operation. And if I minus 1 is greater than or equal to 0, then we'll check if we can come performing the right operation to the present cell. We'll add those corresponding ways and perform a modulo operation. Finally, before printing the answer, we will check if the grid which we are trying to reach has a trap or not. So suppose the rightmost cell has a trap. In that case, you cannot reach it by not going over a trap. So in that case, the answer will be 0. Similarly, if the cell which you are starting from has a trap, then also the answer will be 0. So one way of solving or handling these corner cases would be to check for them here only. That is, you could check for those corner cases here itself, and then here you need not worry about any such thing. But I did not want to do them, so we are going ahead with this approach. I have already submitted the solution. Let's check if it got accepted or, and it got accepted. So do comment down whether you understood the solution or not. Like, share, and subscribe the video, and I'll see you next time.